Hey guys, welcome back. So in the last video, we have been talking about how to delete a node from a circular single linked list. Hope the concept was clear. Now in this video, let's see how does the algorithm of those three cases looks like. So the name of the method is deletion of a node. It takes head reference and location from where the node needs to be deleted. So first we do a check that if the list does not exist, then obviously we don't have anything to delete, so we simply return. Else we go to this else block. If location equals to 0, that means if we want to delete the first element, then what we have to do is we have to create a link between head and node 2. So head is equal to head.next. So instead of 001, this gets updated to 111. Now the next step is tel.next is equal to head. What is tel.next? It is this reference here. So this will become head. What is head right now? It is node 2. So we'll put 111 over here. So this will get destroyed and node 6 will start pointing to node 2. So this is how we can delete the first node. Now there is a corner case that if this was the only element in the list, then we have to do something different. That is, we have to make head and tel null so that the link between head and node 1 and tel and node 1 gets destroyed. And since it is a circular list, this value over here would have been 001. That is, if it is should be pointing to node 1 itself. So this link also needs to be destroyed. So we say node.next is equal to null. So that way node 1 is not being pointed by anything anymore. So it gets eligible for garbage collection. Fine. Now let's say if we want to delete a node which is the last node, then what we have to do is, if it is the only node in the list, then we have to repeat the previous step, that is head and tel and node.next all will be null. Else, that is, if there are more than one nodes in this list and we want to delete the last node. So in this case we see we have 6 nodes and node 6 is the last one which we want to delete. Then what we have to do is we have to run a loop starting from the first node, keep traversing towards right until we reach the second last node. Once we reach there, we say tel is equal to temp node. That is, tel will be updated to temp node. Temp node is node 5 right now. So tel gets 444. So this link over here gets destroyed and tel starts now pointing to node number 5. Now the next step is temp node.next is equal to head. So temp node.next is basically this reference variable here. So this needs to be updated to head. What is head? Head is node 1. So we put 001 here. So this will automatically create a link between node 5 and node 1. So now you see that node 6 is completely isolated and is not being referenced by either node 5 or tel. So automatically it's get deleted by garbage collector. So this is how we delete the last node in a list. Now let's say if we want to delete any other node apart from first and last. In that case, again the steps are very simple. Let's say we want to delete node 5. So all we do is we start from node 1, keep traversing towards right, and we stop at exactly the previous node, which is node 4. Now once we are at node 4, we say temp node.next, which is this part. We need to update the reference of node 4 with temp node.next.next. So what is temp node.next.next? So this is temp node. Temp node.next is this. Temp node.next.next is this. So we update 444, change it to 555. So this will create a link between node 4 and node 6. And the link between node 4 and 5 gets destroyed. So node 5 is now no more being pointed by any nodes. So automatically it gets destroyed. So this is how we delete a node from a circular single linked list. So now let's see how does the time and space complexity of this algorithm looks like. So checking if the list is existing or not is a constant time operation. If we want to delete the first location, then we have to update some of the reference variables. Those are again constant time operation. If we want to delete the last node, in that case we have to traverse till the second last node. So that will take order of n time. Apart from that, all of the steps will take constant time operations because we are just updating some of the reference variables. Now in case if we want to delete any of the internal nodes, then again in the worst case we have to loop through almost the entire linked list. So that will take order of n time. And again the updating reference variables will take constant time operations. So we have mostly all the constant time operations, only 2 order of n time complexities. So when we add all of them, we get order of n. Now space complexity is order of 1 because we are using some of temporary variables here, nothing more than that. So this is all about deletion of a node from circular single linked list. Hope everything is clear. Now in the next video, let's talk about how we can delete the entire circular single linked list. Thanks for your time. See you in the next video.